All right, good morning, everybody. We are now ready to start example 1. So first, let's read the instructions for this problem. It says find all exact solutions for x being between 0 and 360 degrees. So first, this tells us, since we are looking for exact solutions, that we are going to be using the unit circle to find our answers versus our calculator if we were looking for approximate solutions. Next, it tells us that our units is going to be degrees since our interval is in degrees. And it also tells us that we are only looking for not one solution, but a solution that is within one rotation of the unit circle. Now, as we look at this first equation, 8 sine x equals 6 sine x minus 1, the first thing that I would do with this problem is just think about what you would do if this wasn't a trigonometric equation. So we don't have any squareds in this problem, so if this was just 8x equals 6x, since it's sine x and sine x, minus 1, what would we do to solve this basic Algebra 1 problem? Well, this Algebra 1 ground level problem, we would solve by isolating our variable and getting them on the same side. So we would subtract 6x, which gives us 2x equals negative 1. And then divide by 2, so x equals negative 1/2. So sometimes it's helpful when you're looking at these trig equations to think about what you would do if instead of those trig values, you were looking at just normal old variables, because we're actually going to do this same exact thing to solve this problem. We are going to isolate our trig function by trying to get those sine x's together. So I'm going to subtract 6 sine x from both sides. So if I have 8 sine x minus 6 sine x, we get 2 sine x. Now, I'm not going to be picky about the parentheses that they have around the x's there, but remember, I don't want to see just floating signs without any variables attached to them. So make sure you have either a theta or an x with your trig functions. Now from here, how do I further isolate my trig function? We would divide by that coefficient of 2. So sine x equals negative 1/2. All right, folks, now if we were finding the approximate solution using our calculator, we would do inverse sine of both sides to isolate that x. But since we are using our unit circle, we are going to have to find the exact solution and think about what angle or what x has a sine value of negative 1/2. So first, is sine an x or a y value? And sometimes students get confused by this because it's like, but our variable is x. When we're talking about sine being an x or y value, we mean on the x or y axis in regards to the unit circle. So sine means we're looking for a y value. Because our sine value is negative 1/2, we are looking for solutions that have a negative y value of 1/2. So folks, if you haven't already, you'll want to print off that unit circle that's right below the note packet. That also has that formula sheet in that same document as well, because that's going to help us with some of these problems. So first, if my sine of the angle is equal to a negative 1/2, we want to think about what quadrants we have a negative y value in. So my y values are positive in quadrant 1, they are positive in quadrant 2, they are negative in quadrant 3, and negative in quadrant 4. So I'm going to be looking in quadrant 3 and quadrant 4 for this negative y value. So what angle or what x has a sine value or a y value of negative 1/2? So if I look on my unit circle in quadrant 3, we're looking for a y value of negative 1/2. There it is. So what angle has a sine of negative 1/2? That would be 210 degrees. So x is 210 degrees. But what other angle in quadrant 4 also has a sine of negative 1/2? That would be this angle, or 330 degrees. And so we end up with two solutions. So this is going to be kind of the tricky part about solving, is there's the algebra side of things and trying to isolate your trig function, but then there's also the kind of trig side of things of trying to figure out which angles have a sine value of negative 1/2. Sometimes you'll have two solutions. Sometimes you'll have one solution. Sometimes you'll have four solutions. It all depends on what the problem looks like. So on this particular problem, we were looking for a negative y value, which can happen in quadrant 3 and quadrant 4. So that's why we used those two angles. So for example, 150 degrees would not be a solution because the sine value is positive 1/2 instead of negative 1/2. So keep your unit circle handy as we start working through the rest of these problems. So we're going to go ahead and move on to example 2. It says find all exact solutions. There's that exact again, which means we'll be using our unit circle for the interval 0 to 2 pi. So this is important because it tells us that, we are only looking within one rotation of the unit circle, 0 to 2 pi, and it also tells us that our units are radians for this one. Now, if we look at this problem, we've got tangent x times sine squared x equals tangent x. So we see that sine squared x and we go, oh, it's looking like a quadratic trig function. But the problem is we have a quadratic sine value, but then we have just regular old tangent. So folks, if I were going to try to put this in terms of non-trig variables, what this would look like is a times b squared equals a. So why have I set it up like this? Because since I have two different trig functions, I thus have two different variables. So unlike here where it was sine x and sine x, so I just replaced it with x and x, I have tangent x and sine squared x, so I used two different variables. And folks, having two different variables or two different trig functions, so two different variables, or in our case, two different trig functions, that leads to a different way of solving. So first, when I have two different variables, if we try to get them to be on the same side, for example, if I subtract a, we would get ab squared minus a equals 0. So can I actually subtract a from ab squared? Nope, because they are not like terms. So what can we do to isolate these variables if I can't combine them as like terms? This is where factoring comes into play. We are going to take out a as a GCF. So if I take out a from both of those, that will leave me with b squared minus 1. And what this has done for me by factoring is I now have my a stuff separated from my b stuff. And now that it is factored and I have something times something equals 0, either this first something equals 0 or this second something equals 0. So then b squared equals 1. How am I going to solve for b? Square root. So b equals plus or minus 1. So remember, anytime you square root, you have to include a plus or minus. So on this just non-trig version of this problem, we got 3 possible solutions. So, folks, this aspect is important to consider as we start working through more of these, is anytime you have 2 different variables or functions, the only way of really separating those for solving is to take out a GCF. Now, this is where we're going to get into that angry face rule that I mentioned before. You never, ever divide out a variable term. So, folks, how does that apply to the problem that we were just looking at? If I divided out an a from both sides, that would leave me with b squared equals 1, which would lead me to these 2 solutions. But if I divided out that a from the beginning, I have eliminated one of the solutions that a could be equal to 0. So, folks, this is why you always want to factor out the term. We want to factor out a versus dividing by a, which would completely get rid of a solution. So you never want to divide out a variable term. That means anything that has x with it, whether it's sine x or cosine x, you always want to factor it out like a GCF. Otherwise, you'll be getting rid of a solution. So that's why, folks, in this trig problem, we don't want to divide by tangent x. And folks, I actually want you to put a star by this. And just put don't divide out. So don't divide out a tangent x. Instead, we need to factor it out. Well, folks, before we factor it out, remember, in order for you to factor and use the zero product property, the equation has to be equal to 0 first. So, how are we going to get this equation to be equal to 0? We're going to subtract tangent x from both sides, keeping that squared term positive. So minus tangent x minus tangent x. And again, we can't subtract these because they are not like terms. So I get tangent x sine squared x minus tangent x equals 0. So now we can take out a GCF. So instead of dividing by tangent x, we factor it out from both of those terms. So tangent x and then sine squared x minus 1. So just remember, folks, when you take out a tangent x from tangent x, you are taking it out by division. So that's why you get a minus 1 here. Equals 0. So now I have something times something equals 0. So that means either this guy is equal to 0, so either tangent x equals 0, or it means this guy equals 0. So sine squared x minus 1 equals 0. So tangent x equals 0. So now I have my trig function as isolated as it can be. So we want to think about where tangent is equal to 0. So what angle x has a tangent of 0? So first, tangent is y over x. So if I need this to be equal to 0, essentially, we need the y value to be equal to 0, because 0 divided by anything is 0. We just can't have that x value be equal to 0. So going to my unit circle, where do I have a y value of 0? Here at 0 radians, my y value is 0, so y over x, 0 over 1 is 0. And then here at pi radians, because 0 divided by negative 1 is also 0. So my two angles would be 0 pi and pi. Or you can just say 0 and pi. So those are my two solutions for that part of the equation. Now I have to go and solve this other piece, sine squared x minus 1 equals 0. So I would add the 1 over to the other side, so sine squared x equals 1. Now, how do I isolate this trig function to be a single sign? Square root, square root. And when I square root, sine x equals plus or minus 1. Please, 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 please do not forget that plus or minus in front of the 1, because otherwise you will be losing some of your solutions. So, where does sine of an angle equal positive or negative 1? So remember, sine means the y value. So where do I have a sine of positive 1? At pi over 2. My y value is 1. Where do I have a sine of negative 1? At 3 pi over 2. That's when my y value is negative 1. So from here, x is equal to pi over 2 and 3 pi over 2. But before we put a box around it, we have to check for extraneous solutions. So as we mentioned above, you check for extraneous solutions anytime you have tangent of theta involved in an expression, because if you have tangent, you have to make sure that you're not dividing by 0. So these I got from my tangent function, the 0 and pi, so those are all hunky-dory, but I need to make sure that these two actually work in our original equation when we plug into both trig functions. So it's fine in the sine function, but these two angles need to also work when I plug back into the original equation. So if I want to find the tangent of pi over 2, tangent of pi over 2 would be y over x, or 1 divided by 0. Wah, wah. That is undefined. The tangent of 3 pi over 2 would be y over x, or negative 1 divided by 0. Wah, wah. So these two solutions are extraneous because they are undefined in the tangent function. So that means my only two solutions for this problem are 0 and pi. So you only need to check for extraneous solutions if you have a tangent anywhere in the equation. Otherwise, you are good to go with the solutions that you find. So folks, we're going to go ahead and stop this video here, and we'll resume the next one with example 3.